Ever wondered how a single entity can exist in many forms? In the world of programming, there is a concept called polymorphism that allows us to do just that. Let's break it down. The term polymorphism comes from the Greek words poly, meaning many, and morph, meaning forms. So, in essence, polymorphism is about one entity taking on many forms. But what does that mean in the realm of programming? Well, in programming, polymorphism refers to the ability of a variable, function, or object to take on multiple forms. It's a bit like a chameleon, changing its color based on its environment. Similarly, a polymorphic variable, function, or object can behave differently depending on the context. This ability to morph and adapt is what makes polymorphism such a powerful tool for programmers. It lets us treat different objects in the same way, leading to code that's more flexible and easier to manage. So, in a nutshell, polymorphism allows us to treat objects of different classes in the same way, which makes our code more flexible and easier to manage. Now that we have a basic understanding of polymorphism, let's delve deeper into its applications and benefits in programming. To start, polymorphism comes in two main flavors, compile time and runtime polymorphism. But what exactly does that mean? Let's break it down. Compile time polymorphism, also known as static or early binding, is determined at, compile time. It's like planning your day ahead of time, knowing exactly what you're going to do and when. In the programming world, this is achieved through function overloading and operator overloading. Function overloading is like having a toolbox with different tools, all called a hammer, but each designed to handle different tasks. Similarly, operator overloading is like using a plus sign not only for adding numbers, but also for joining strings, combining lists, and so on. On the other hand, we have runtime polymorphism, also known as dynamic or late binding. This is like making decisions on the fly as your day unfolds. In the realm of programming, this is typically accomplished through method overriding and virtual functions. It's like having a basic plan, but with the flexibility to change specific parts of it if needed. Now, you might be wondering, why should we care about polymorphism? Well, it provides a host of benefits that make a programmer's life easier. To start with, it promotes code reusability, saving us from reinventing the wheel every time we need similar functionality. It's like having a recipe that you can use to whip up different dishes just by altering a few ingredients. Moreover, polymorphism allows for dynamic method dispatch, which is a fancy way of saying it enables an object to decide which method to invoke at runtime. Think of it like a traffic signal that changes color depending on the traffic situation, ensuring smooth flow. In the same way, dynamic method dispatch makes our code more flexible and adaptable, enhancing its overall efficiency. As you can see, polymorphism is a powerful feature that allows for a high level of abstraction in code. But what does polymorphism look like in the real world? How do we encounter and use it in our daily coding practices? Polymorphism in its essence is about one interface, multiple methods. It's like a universal remote control that can operate a TV, a DVD player, or a sound system. Each device responds to the same command, but in different ways, depending on its nature and functionality. That's polymorphism for you in a nutshell. Let's take a closer look at some real-world applications. Suppose you're a game developer. You're building a game that has several types of characters, each with different abilities. Polymorphism allows you to use the same method, say, attack, for each character. But how this attack is executed will depend on the type of character. A knight might swing a sword, a wizard might cast a spell, and a rogue might fire an arrow. Each character responds to the attack command in their own unique way. In another instance, think about a drawing application. You've got various shapes, circles, rectangles, triangles. Each shape can be drawn, but the way they are drawn is different. A circle is drawn with a center and a radius, a rectangle with length and breadth, and a triangle with 3 sides. The draw method here is polymorphic. It's the same command, but the execution differs based on the object it's applied to. Polymorphism doesn't just make our code more understandable and organized, it also makes it more extendable. If we decide to add a new character to our game, or a new shape to our drawing application, We only need to define how the new object responds to the existing commands. We don't need to modify the existing code, making our code much easier to maintain. Moreover, polymorphism promotes code reusability, reducing redundancy, and making our code more efficient. It's a powerful tool that helps us write cleaner, more flexible, and more efficient code. So, the next time you're writing a piece of code, ask yourself, could this be more polymorphic? Could I make this code more flexible and efficient by utilizing polymorphism? Remember, polymorphism is all about flexibility and efficiency in your code. So, let's quickly recap what we've learned about polymorphism. Polymorphism, from the Greek words poly, meaning many, and morph, meaning forms, is a fundamental concept in object-oriented programming. It allows us to perform a single action in different ways. In simpler terms, polymorphism allows us to use one interface with different underlying forms such as data types or classes. We've discussed two types of polymorphism: compile-time polymorphism, also known as static, and runtime polymorphism, also known as dynamic. Compile-time polymorphism is achieved through method overloading and operator overloading. It's determined during the compiler time. On the other hand, runtime polymorphism is achieved using method overriding, and it's determined during the execution of the program. The benefits of using polymorphism are numerous. It boosts the reusability of the code and makes the program more easily extendable. It allows for cleaner and more efficient code, reducing complexity and increasing maintainability. It's also key in enabling a single variable to control multiple objects, thus creating more flexible and dynamic programs. We've also looked at real-world applications of polymorphism. Think about how a single button on a remote control can perform different actions depending on the device it's connected to. That's polymorphism in action. Or consider how a mobile phone can take on multiple forms, such as a camera, a music player, or a web browser, all based on user interaction. To reinforce the concept, consider a simple example of a shape. A shape can be a circle, a square, or a triangle. Each of these shapes has a method to calculate the area, but the formula varies depending on the type of shape. This is a clear example of polymorphism where the same method behaves differently depending on the object. And that's a wrap on polymorphism, a fundamental concept in object-oriented programming that allows for versatility and efficiency in our code. Keep exploring, keep coding, and remember to embrace the power of polymorphism in your programming journey.